I'm here talking with Pete Savagian, Engineering Director of General Motors' Electrification Architecture and Electric Motor Release Center. Pete's also managed product development and advanced engineering for GM's hybrid systems. Sometimes we fight for 2 and 3% more efficiency, for instance, in the inverters and the choice and design of motors. And I just wondered how that implication, the efficiency of the car, is not the be-all and end-all of the purchase decision. How you take that into try and balance that as you're making drivetrain decisions and architectural decisions.
Well, I think the Spark EV is probably the case in point, is that we understand that the electric vehicles have, we don't go into it to say, here's a Spark EV, it does everything that your Chevy Tahoe can do, or it's just as comfortable as our Chevy Impala. It can carry all the stuff and has the great utility and capability of a Chevy Equinox. It wasn't that. And, it's a BEV, and we could make it, we're very proud of its efficiency everywhere, and that is a big objective. But on the other hand, I think an electric car can do quite well is just give great performance. That if we made that car with a 50-kilowatt motor, I don't think its range would be any shorter or longer than it is today with, 110 or more kilowatt drive. But the car is so much more enjoyable to drive, and we know that certain things excite this enthusiasm and passion, and it's not necessarily a rational thing. It's just a fun thing. And people buy cars for lots of reasons, but we think that people like to buy fun cars, and so we made that car fun, and we put more power into it. And it came at a certain amount of cost. It really was the right thing to do, I think, to give that car its fun-to-drive character. So there are a lot of choices we can make, some of them for efficiency, but maybe the perfectly efficient automotive appliance would be boring and not have customer appeal. So it all goes into the equation. We should play to the strengths of what an electric vehicle has to offer, and that is we can make them quite exciting to drive. We can make them smooth. They can be very reliable. They can be quite quiet. They can have a low inertia driving feel, and let's deliver to the strengths of the application what is our thought. And so that's the kind of calculus that goes into the formulation of the drivetrain. It's not strictly an efficiency exercise. It's a big part of it, but it's not strictly that. It's much more than just efficiency.
Absolutely. I think the area that we're talking about now, costs and efficiencies, of course, is what determines the dynamics of the growth of the market, as well as the emotional attachment that you alluded to. Part of what prevents plug-in vehicles and battery vehicles taking off is their higher purchase price. But besides the cost of the motor, and you mentioned the induction motor perhaps has a cost saving, what other ways do you see in the future, kind of defocusing your mind for a moment, that we might hope for reducing the manufacturing costs of these battery and plug-in vehicles?
Well, it seems like we're on a trend now where the costs have been coming down and are coming down. I think it's fair to say that the electric motors and mechanical elements of the drivetrain are the most well-known industrial art, but still we see generational improvements on motors and motor technology. Beyond that, the electronics are moving at even a faster rate. And then further up the food chain, though, the big thing, the batteries really moving at the fastest rate. The energy battery improvements in their cost and durability metrics are just moving right along, so that even though it's not the obvious low-cost choice today, I think the trend would indicate we're years away from that, maybe 5, maybe 10, maybe 15 years away, but the trend is continuing, has gone and is continuing, and the research continues strongly as well. So it may well be that the most economical transportation could be fully electrified in some future period of time, that we want to make sure we're prepared for that. We understand all the keys to industrial production and what kind of features really belong in those cars, all the great things that can be done to communicate with them while they're charging, while they're driving, that are unique to an electric vehicle. We need to prepare for that period of time. And we think there's a market here and now for these extended range and plug-in vehicles that's quite substantial, that we can excite, that we actually make money at in production with vehicles that have both an electric and a gasoline character. I think that kind of primes the industrial pump of technology development and generational learning of moving the technologies along in all these key areas, the motors, the electronics, and the batteries. So we, GM, are participating heavily in the space because we intend to be selling vehicles for a long time.
That's a nice summary of a strong hope for the future and a realistic view of timescales and how this is a longer-term game than only next year's vehicle.
Right.
Pete, thanks very much for joining me today. It was interesting to learn more about the motors and the powertrains in your existing and future vehicles and your thinking there. I appreciate your time and wish you much continued success.
Thanks very much, Malcolm. I appreciate the opportunity.